Welcome to part 3. It's time where we're going to be talking all about the future of space, and the speakers coming up are truly out of this world. I did not realize the pun was coming until it was out. I do apologize. But it's the future of space, super exciting. But before we get into all that, I think it's time we do another bit of interactivity. So the plan for this time is we want every single person, every class listening at home, and even if you're here right now, we want everybody to take a selfie, and we want you to upload it to your story or your post or anything you want with @FuturePortYouth and hashtag FPY2022. If we can get the requirements on the screen, please. There you go. That's what you're after. So @futureport.eu, that's our handle for today, and hashtag FPY22. Share some love on social media. Send them in. That's hashtag FPY22 on Instagram, Snapchat, TikTok, whatever you wish. I can't wait to see all these afterwards. I'm going to go through it. And we even want one of our own. We've got Martin with the very nice long arms to do the task. Martin, can we do the selfie? Selfie with the room. Your arms are better than mine.
There's a lot of light. Can we turn these lights down a little bit? Maybe not. Thank you. And we have some questions.
Yes, and now it's time. We're going to get back on Minimeter. We've got some more questions for you, which I can see some people are already voting on. That's menti.com. And the question is, right now, do you believe that space travel will become as easy as hopping on a plane in your lifetime? Probably yes, the majority. I hope so. I think it should be a question in itself, who'd be willing? Raise your hands if you'd be willing to go to space. But that's more than expected, you know? Maybe just everybody where I'm from is too scared of it. The wimps. Definitely yes, probably yes, not sure, probably not. Oh, no way. Who said no way? Who's the pessimists? It's interesting, and honestly, seems though a lot of people want to do it. Why not, you know? We've got some astronauts here today who've actually been to space, designing the rockets and all sorts. So who knows, we'll get you on the next one. And the next question, can we get that up on the screen? Is when Mars colonization is open for everyone, will you go? I'd only go as a tourist. Get lost, I'm not leaving Earth. I love how passionate these responses are. You got, yes, I would move there immediately. Yes, but rather later. I'd go only as a tourist, or get lost, I'm not leaving Earth. I would go as a tourist. We all just hop on a rocket for a holiday to Mars. That's interesting, though. Nice to think about, you know? Who knows? That could be our future. I mean, no promises. I'm not clued up in this sort of thing. But that would be great. Optimism, optimism. Okay, thank you so much for taking part in that. And now I guess it's time for us to get back into the talks. Next up, we've got Jakub Rosa-Hinal, who is a director of Planetum Observatory and Planetarium of the capital city of Prague. Jakub specializes mainly in small bodies of the solar system, in particular the study of asteroid families and the study of the decay of small bodies. He lectures on astrophysics at the Faculty of Electrical Engineering, Czech Technical University, and he's also involved in popularizing astronomy, physics, and related science, having given dozens of popularizing lectures and as an author of many books. So, guys, ready? I'm not forgetting this time. Standing ovation for Jakub Rosa-Hinal. Welcome, Jakub. Very great to have you here. And you actually, at your museum, have the first planetarium and the first satellite in your planetarium, which is big news, because it's actually local. Great to have you here.
Well, thank you. Well,
I'll let you take it away. Cool.
thank you. Well, thank you for interaction. My name is Jakub Rozenal. I'm head of Planetum, which is the largest platform for astronomy popularization in Czech Republic. It's composed of two observatories, Štefánik Observatory on Petřín Hill, 20 minutes by walk from here, and a small observatory at Diablice, and also Prague Planetarium, which was founded in 1960. At that time, it belonged to among 10 largest planetarium on the world. At present, it still belongs among largest planetarium in the world, with the dome with diameter about 24 meters. But we decided to close it and renovate it, improve it with cutting-edge technology, with LED projection system. After about 1 year, I hope, in 1 year we will be the largest planetarium of its type on the world. It's due to the kindness of Prague government, which gives us really large amount of money, about $10 million. But before we will close, we hope to host many school groups to communicate via our own satellite. Last year and this year we became the first planetarium in the world which launched its own satellite for educational purposes. Actually, I'm an astronomer, astrophysicist. I'm engaged in hydrodynamic simulations of protoplanetary disks and collisions between planets and protoplanets. So for me, the table is full of electronic mess. And it is probably what is the satellite composed from. So I recognize here. I recognize here the pointer. It's okay. So I recognize the orientation system, and there are two computers, two antennas, two cameras. Like in the human body, what is important, we have in pair. 2 hands, 2 legs, 2 lungs, 2 kidneys, and so, but only 1 head. It's interesting, isn't the head important for us? Maybe legs are important when you want to run from danger, but legs are moving yourself, but your head can move the whole mankind. That's why we decided to launch a satellite for educational purposes. Here is it packed in pillowcase to move to Germany, to Exolaunch company, where it was loaded to so-called deployer. Deployer is a box where our satellite lives together with another one. Of course, when you are launching a small satellite, this is a cube, 10 to 10 centimeters. So it would be really very expensive to launch it just itself. So our satellite was launched together with 58 another satellites. Of course, we had to build a command center. It is built in Prague Planetarium foyer. It's open to public, so you can visit it free of charge. This is a place from where we are sending messages or commands to the satellite, and we are receiving also data from the orbit. This is a launch of Falcon 9 satellite. It's I think 25th mission. It's a 70-meter high rocket reaching orbit in about 8 minutes. And you can see here a cut of the first stage of the rocket and burning of the engine of the second stage, which delivered the payload to the orbit in height about 530 kilometers. And when it is on this orbit, it is time to remove the air shield, because there is no air, so you don't need to have aerodynamic shielding. And now you can see deployment of satellites from the deployers. As I told, there was about 60 satellites, and between them, among them, there is also our own. I think it would be. No, I miss it. Well, so this is how our satellite looks like. You can see the names engraved on the top. They're names of employees of Planetum, of my colleagues. It has also unfolded antennas, which are folded to for the move to the orbit. And there are systems inside, batteries, computers, etc. And you can see on the top also our passenger. People from Czech Republic know it very well. It's Hurvínek, very famous figure, like Mickey Mouse for the others. To communicate with a satellite, we have also our communication system. This is an antenna on the rooftop of the planetarium. To obtain highest signal to noise ratio, we need to point the antenna exactly to the place where the satellite is actually on the orbit. So during the flyby over the horizon, which lasts about 5 minutes on average, this is our only chance to send data to the satellite. To receive data like temperatures and other data from sensors and pictures, we can receive it through the whole world, through the SatMox network. And this is a first picture from the orbit that proves that everything went all right. The passenger is not there just for fun. It is to engage also smallest children to space and cosmonautics and etc. As I told you, this is for educational purposes. So school groups and groups from high school or universities should visit, could visit planetarium and learn how to write a code to send some message or so, some command to the spacecraft, not spacecraft, a satellite. And we also hope there will be some students of high schools or universities which who will help us to assemble the second satellite, Planetarium 2, which is planned to be twice as large as Planetarium 1. And I hope it will have really scientific or some purposes like, I mean, it will obtain useful data for public, for example, agriculture, or some data regarding national resources, or data regarding local climate state or so. So actually, this is a satellite for you. Thank you for your attention.
Don't think that you go up that he finishes that.
Thank you.
Thank you.
And we have one question for you right now that we have time for, and that is, do you remember the first time you became interested in space?
Actually, it's a long time ago.
Long time ago.
I was, I think, every time interested in natural sciences, mainly chemistry, because my dad is a chemist. But I started to learn about space about 12 or 13-year-old when I opened a book from very well-known Czech writer and former director of planetarium, Antonín Rykl. The name of the book was Images from Deep Space or so. This was the first time I meet the space, and I started to visit the astronomy course at our planetarium, and I became an employer and head and blah blah blah.
Amazing. Well, you've been very successful to have the first satellite launched and owned by a planetarium in the Czech Republic. That's mad. So congratulations, and we really appreciate it.
Thank you. Thank you.
Okay, so next up, we're going to hear from a man called Gary Lai. Gary is one of the most renowned aerospace engineers. They're responsible for setting the technical direction of human spaceflight programs at Blue Origin, a company started by Amazon founder Jeff Bezos. Blue Origin aims to create a future where millions of people live and work in space to benefit us here on Earth. So, I don't know about you, but this really intrigues me. I want to welcome to the stage, please, Gary Lai with a standing ovation.
Thank you very much, Tilly.
No problem at all. I've researched you so much.
I've researched you a lot as well.
I'm so looking forward to this, so I'm going to sit myself down.
Sure. So, thank you, Tilly. Thank you, Futureport, for inviting me here. I'm very happy to be here talking to everyone about a subject that I'm extremely passionate about, and that is the new space age. So the current space age, the first space age, it's not often that you can point to a specific date that an era in history started, but for the first space age, we can. And that date was October 4th, 1957. And on that date, the Soviet Union took a rocket that they were developing to launch nuclear bombs across to other continents, and instead put a little satellite, Sputnik, in it and launched it into orbit. And that everything has changed since then. This space technology has made such an impact on your lives, and it's so embedded in our daily culture that you might not even realize it, or you will take it for granted. But we are at the dawn of a new space age where there is an explosion of new activity, and that started on a particular date as well, about 7 years ago, and I'll talk more about it. So what will happen in this new space age? Well, it's really up to not people in my generation, it's up to people in your generation, because there's going to be so much possibility. So at the end of the first space age, the old space age, there are currently over 5,000 active satellites right now. And I'm not even counting small CubeSats. I mean 5,000 active satellites that are about the size of a car to the size of a bus. They're flying overhead right now. They do so many different things. Well, space exploration has changed the way that we view ourselves in the universe. We've been able to travel to the furthest reaches of the solar system, like Pluto. We have telescopes that can stare into the deepest depths of time. But also, in your everyday life, if you look at a weather forecast every day, which I'm sure most of you do, you're looking at a highly accurate weather forecast because of satellites. Or because maybe you navigate it here with your phone, with Google Maps, or some other product, and that is possible because of satellites. And we have imagery now of every single square inch of the Earth, and your communications, whether you make a phone call or you surf the web, you might not even know it, but many of those signals are traveling over satellites. And of course, we currently have a small group of people that are living in space all the time in an International Space Station. So not only is there a lot happening, there's a lot of launches. 150 times a year, every couple of days, something launches into space. It's also a tremendous business. Right now, the space economy accounts for about 500 billion. I actually had to have a little typo I just recognized there. It's 500 billion in annual economy, and it is growing at about 10% per year. It's one of the only parts of the economy that is growing so fast. And it's projected that we will reach about $1 trillion economy by the year 2030. So that's bigger than the economies of most countries in space. And one of the remarkable things is that this is happening even though rockets fail all the time, or they have in the past. At the end of the old space age, or the first space age, only 620 people have ever traveled to space. And I have the luck of being number 600, which I'll talk a little bit more about. But it's been about 60 years, and that means it's been less than 10 people per year have ever been to space. And one of the reasons for that is 2% of all the people, 1 in every 50 people that have tried to go to space have died in the process, either going up or coming back down. So it has not been as safe as it could be. It's also very expensive in the past to fly to space. It's about 10,000 euros per kilogram that you get to space. So it's extremely expensive, and yet even at those high prices, you've had this 5,000 satellites that are actively working in orbit right now. And why is it so expensive? Well, it's because we throw away the rockets every single time. So imagine if you wanted to fly from here to across the ocean to Asia or the United States, and you had to throw away the airplane when you were done. You landed and said, okay, goodbye, and you threw it in the trash. The ticket would not be 1,000 euros to fly across the ocean, it would be 1 million euros. And probably no one in this room would really do it because it would just be so expensive. The thing is, And the reason the new space age has started is because we are starting to learn to reuse the rockets. And that takes me to the project that I've worked on for quite some time, the New Shepard vehicle. I've worked on New Shepard since the very beginning, and since it was just a little sketch, and all the way through until now it's operating and it's flying. So New Shepard is named after Alan Shepard, who was the first United States astronaut. It can accommodate 6 passengers. There is no pilot, it's completely robotic. It flies itself. And it goes about to 107 kilometers altitude, which is definitely in space. It's above 100 kilometers, which is what the boundary of space is defined as. There are incredibly large windows. They're so large that when you're looking through them, you can't see anything else but through the window. You experience weightlessness. And the key thing is that it's completely reusable. It's designed to be used 100 times. And New Shepard is for space tourism. You can go and you can buy a ticket, you can fly to space and have the adventure of a lifetime. But that is not actually why we're doing it. It's not why I'm doing it for tourism. It's because we are using this vehicle to learn how to reuse rockets so that someday people can travel to space routinely for many different purposes. It might be for tourism, but it might be to visit family. It might be to do business in space. So on March of this year, March 31st of this year, I had the opportunity to fly on New Shepard myself on the 4th flight. The 4th human flight, but the 20th launch overall. So New Shepard consists of 2 parts. There is the booster, which is the lower part of the rocket, and then there is a capsule where we're sitting. Is there a sound? There we go.
And lift off. And ready for tower.
So it was a complete thrill for me to have been, the lead designer. There's a team of about 150 people that designs New Shepard, but to be the lead designer of that group from the very beginning and to actually be able to ride it into space. And then in space, it separates and you experience weightlessness. You can look out those huge windows. That's me doing a somersault. And this is the view. This is the actual view out of a window of New Shepard. You can clearly see that, yes, I can confirm the Earth is round, and you're above the atmosphere, and it's so thin. And above that, you see complete blackness. In space, you don't actually, when you're in space, you don't see stars because the Earth is so bright. You just see the blackness of the void. But the real unique thing about this rocket, other than now people can go out and buy tickets for it, which is something that has never been possible. You had to go with a government program. You had to be a government astronaut to fly to space. Now anyone can do it, is that it lands vertically. So that's the booster without the capsule. The capsule's flying itself freely, and we can pinpoint land it pretty much anywhere on a little postage stamp if we wanted to. And that never gets old looking at that. It's remarkable to see it. And then the capsule, we come down separately in the capsule under parachutes, 3 parachutes. Those are for redundancy. We can actually land on a single one of them if we needed to, and there's a retro rocket that goes off just before landing, so it's actually quite a soft impact.
Welcome back to Earth, astronauts.
So I was very happy. And maybe someday you can have that experience too, I hope. Maybe after this, like after the poll before, maybe the numbers would start to go up after watching that. A lot has happened since then. So we landed New Shepard for the first time in November 23rd, 2015. That was the first time in history that a rocket had launched to space and did a soft landing for reuse. And I count that as the start of the new space age. SpaceX, obviously, you all have probably heard of SpaceX. SpaceX matched the feat in December of 2015, just about 4 weeks after we completed it. And since then, rocket landings are relatively routine. We were testing the vehicle without, it's a robotic, so it doesn't need a pilot. We were testing it for years to make sure it was safe enough to fly people. And we conducted our first human flight in July of last year. And since then, we have done a total of 6 human flights, and we're starting to ramp up the pace. SpaceX is also now in the orbital space tourism business. The difference between orbit and suborbit is really just the duration of the mission. The New Shepard mission is relatively short because we don't go all the way to orbit, but they can stay up there longer because they're going faster. And, but the launch and the landing, they still have a single launch and a single landing. So SpaceX has conducted their Inspiration 4 mission, and now that was an all-civilian crew. Every single person on board they were not SpaceX employees, they were astronauts because they just signed up and said, I want to do this. And now this is possible. And so now rocket landings and reuses are completely routine. 170 times in those, since 2015, we have launched and we have landed a rocket and reused it. And the current record, and it's still climbing, is that we have reused a rocket 14 times. Most of us are attempting to reach at least 100 to start with. We're gonna go beyond that when we get to that goal. And have a picture here also. So what we are doing in Blue Origin with the New Shepard vehicles, we are learning the techniques to do this on a small scale. We are building a much larger rocket called New Glenn that will actually be bigger than the Falcon 9. It's in construction right now and will fly next year and land after it launches from Florida in the United States. It will land in the ocean on a ship, similar to how SpaceX does it. So my prediction is that what you're going to see is a very, very dramatic decrease in the cost of launching to space. So in the last 7 years, by various measures, it's gone down already by a factor of 10. So that 10,000 euros per kilogram is more like 1,000 euros per kilogram now. And we're going to see in the next 8 years, as we perfect these techniques and other competitors come in, that it's going to go down by another factor of 10. So it will be 100 times cheaper to launch something into orbit than it was just a few years ago. Safety will also increase by that amount, so that even if you don't think it's safe now, the data will not support it. It will be perfectly safe to fly to space. So what will this mean? Right? What will it mean to markets? What will it mean to the activity in space when it's 100 times cheaper to fly there and 100 times safer? I have some ideas here that I'm going to talk about, but really it's up to the people in this room. It's up to the people listening online what that will mean. So what I hope it means, and really the mission of Blue Origin, the reason we exist, is we are going to space to benefit Earth. And we've talked throughout this morning, like the future of energy talks, about how we really are in a climate crisis. We are using the Earth's resources at an unsustainable rate, according to the United Nations. We are currently using various resources at about twice the rate that could be sustained indefinitely. And that's still growing, right? The human population is growing. There are people in poverty that are coming out of poverty, but as a result, they use more energy. So by 2050, we're going to need 3 Earths to support human activity. And if we were to get everyone that is currently in poverty, in abject poverty in the developing world, to live like we do in the West, in the developed world, in the developed countries of the West and Asia, which we should hope that they have a better quality of life, well, we would need 5 Earths. We only have 1 Earth here, and so that's unsustainable. And so if we only focus on the finite resources of the Earth, we can do a lot with conservation, we can do a lot with smart use of energy and smart use of resources and recycling. But ultimately, with the finite resources of Earth, we're going to reach an equilibrium where we will have to pause population growth and we will have to pause economic growth. And that's what we're trying to work. How do we get outside of that? How can we grow the human species even more? And I believe that in the new space age, that will be the driving force. We will use the resources of outer space to benefit Earth so that humanity can prosper and grow more and that we can leave our ecosystem intact. Because the solar system has abundant resources. There are a lot more than 5 Earths in the solar system in terms of resources. There are hundreds, if not thousands, of Earths if you look at just the resources of the solar system. Let me give you one example. Think for a second about the sun. Pretty much all the energy that we use today on Earth comes from the sun, even fossil fuels, right? Fossil fuels are decayed plants and animals from millions and billions of years ago that grew because of the energy of the sun, because of photosynthesis. Or wind energy is because the sun heats the Earth's atmosphere and land at different rates, and it drives wind. Or we directly use solar power in the form of solar panels. So we get all our energy, except for a little bit from nuclear energy, directly from the sun. And yet, we're 150 million kilometers away from the sun, and we're intersecting just a tiny little bit of the energy that it's spewing in all directions. In fact, the sun is spewing so much energy that it could bathe the energy of 1 billion times 110 million Earths. That's how much energy there is spewing in the space. There is no energy crisis in space. Okay, there is unlimited energy in space. And so one way that has been studied to reuse that is to actually put solar power stations in space. And to beam that energy in the form of high frequency radio waves. It's perfectly feasible. It's a feasible technology. The advantage of that is the sun doesn't set in space. There are no clouds. You get basically constant year-round energy. You can beam the power to where you want it. You can even beam it in beams directly onto the roof of your house or into a substation or into the remote desert. There is no transmission loss. To get it over by long wire. And so this is feasible, but the conclusions from these studies, and this image actually comes from the European Space Agency, is that you needed to get launch costs down by a factor of 10 in order for this to compete with fossil fuels and other coal-fired power plants. Well, when the launch costs are down by a factor of 100, this will be the cheapest way to produce electricity. But there's yet another more compelling reason, and that is the moon. And the moon's been called the 8th continent. And I love that term because the moon is actually part of Earth. The moon was formed about 1 billion years after the formation of the Earth, when a planet struck the Earth and it split it apart into 2 pieces, and one part became the moon. So the moon is Earth. It is created and has the same material as the Earth does. Everything that we have on Earth exists on the moon. Things like silicon, metals of all types. Actually, if you were to take a handful of lunar soil, 15% of it is metal. It's aluminum, it's iron, it's titanium, it's manganese, it's all different kinds of metals. And by the way, with silicon and metal, you can make solar panels. You could make every single solar panel to supply the entire Earth with just a very small part of the moon. There's hydrogen, there's oxygen in the form of molecules called hydroxyls that can be combined to form water. There's actually water on the moon. It's in the form of ice. It's in deep in craters, an estimated approximately 1 billion metric tons in the form of ice. So it's basically an unlimited supply of water on the moon, rare earth elements, which we need for all sorts of industrial products, including batteries and circuit cards, carbon, nitrogen, a whole lot more. Everything we need to make an industrial civilization exists on the moon. In fact, in greater quantities. Because the moon is, you can think of it as, it's a core of the Earth. And so we would have to dig very deep into the ground, into the mantle and beyond in order to access the resources that are on the surface of the moon. I love this quote. If God created man, sorry for the misogynist aspect of it, but if God created man to become a spacefaring species, he would have given man a moon. And we have one. So with launch costs in the new space age, a fraction of what they are today, in the past, we can become a spacefaring civilization. And we are in fact doing that. We're finally going back to the moon after many years. Humans are going back to the moon. So next week, hopefully, NASA will finally launch its Space Launch System rocket. That is very much a relic of the old space age. It costs $4 billion to launch that. And so not even NASA cannot afford to do it more than once every other year. But it will kickstart a lot of activity. Of course, SpaceX is developing a starship, a lunar starship to land on the moon that will be much less expensive. We at Blue Origin are developing a lunar lander as well in partnership with other companies. And smaller landers are flying too. In fact, these small landers are also funded by NASA. The very first one, they will fly 2 per year. Universities, companies can rent payload space on these landers. The very first one will launch in a few months on a rocket called Vulcan that Blue Origin is providing the engines for. So what are we going to do when we get to the moon, when we get back to the 8th continent, and we have an industrial infrastructure? We can continue to do science. So just one example, NASA is planning, in the early stages of planning, a telescope on the far side of the moon. We won't be able to see it from Earth, but it will not be clouded by the light from the Earth. And it will be the most powerful telescope ever created, built into a crater for radio astronomy. Or we might build cities on the moon. And at this point, in this next couple of minutes, it's going to sound a bit like science fiction. But this is what even people in my generation are inspired by science fiction, and what was science fiction in the past is reality today. At Blue Origin, we don't think this is what the future of life in space will look like. We're not sure, but we are inspired more by images like this. In fact, this image is emblazoned on the wall of our headquarters. This is a concept called the O'Neill cylinder, which was invented by Gerard O'Neill and his students at Princeton University in the 1970s. The idea is that if you can readily access the resources on the moon, then you can take all that metal, all those materials, and you don't need rockets. You can actually launch them off the surface of the moon with electromagnetic energy on a rail into lunar orbit and construct large habitats. This particular design is 32 kilometers long. And it was meant to house several million people. And the interior, who knows what the interior would look like, but the idea is that it's spinning, it's rotating, so that on the inside, it's so big you can't tell it's rotating, you feel gravity. You could have natural like Earth gravity inside. There would be a large atmosphere, there could be parks, there could be lakes. This is when we say at Blue Origin that we are working towards a vision where millions of people live and work in space, we're actually talking about this kind of vision. So maybe in your lifetime, I certainly think this is possible, maybe it looks completely different. But this is what I mean by ultimately the new space age, or even space 3.0. So what will happen in the new space age? I actually don't know for sure. I'm giving you some ideas really to inspire you, but that is completely up to you, the people in this room. And it is being enabled. We're trying to set the road where we're radically lowering the cost of access to space so much that all these things are possible. I'm going to close with a few resources. If you're interested in learning more, of course, you can look at the Blue Origin website. It tells you more about what we're doing. If you're engaged a lot with, say, YouTube channels, I would recommend Scott Manley. He is from Scotland. He makes an excellent series of YouTube videos. He has over 500 million views about all aspects of the newest space economy. And if you're a college student and you really want to get into it and you know calculus and you know physics, Rocket Propulsion Elements by George Sutton is the Bible of rocket scientists. It's the book that we all learn, and if you want to learn how to design a rocket engine. Anyway, thank you very much.
Well-deserved standing ovation. That was so interesting. Genuinely, I have so many questions myself, but I want to put it out. I'm going to hold myself back, and we're going to hear questions from schools and anybody who has any who they want to ask right now. But we've already got a couple here. So just to start off, Gary, what would you wish to future generations?
I would wish for all future generations, and I include my children, that you live in a world that's better than the one we live in. And I think that's certainly what I'm seeing. So there has never been a better time to be alive. I hope you realize that. It might sometimes seem like the world is falling apart and that we have so many problems, but by any objective measure, there's a higher quality of life and more opportunity than ever. So I hope that I wish that you have hope that the world can be a better place.
I really like this question, which is, which planet does Gary think is the most suitable or has the biggest potential to be colonized by us?
The moon, the eighth continent. Not necessarily the moon, but as I talked about there, I'm not so convinced that Mars is the right place to colonize. It is so far away, and it really doesn't have anything on the moon in terms of resources. So, depends on where you want to live.
Do we have any questions from the online classes? Somebody let me know.
Hi. We at Gymnasium Żydłow-Powice have a question from one of our students. What do you think about the fact that a lot of former astronauts, maybe Neil Armstrong, and how they are against commercial space travel?
What do I have against former astronauts? So I don't think that's a universal opinion. They're certainly entitled to their own opinion. But I have worked with a dozen astronauts that are employed at Blue Origin, including former space shuttle astronauts. So they certainly are believers in the cause. I think that basically, if you were in a traditional government program for many years and worked at NASA were a NASA astronaut, then maybe you would feel like this is not something a commercial company can do. They would never accumulate the expertise. But we've proven that is not the case, right? Most launches today are being done by commercial companies and very few by government agencies.
Anybody else online got any questions for us? You can shout out or let me know if you need it unmuted. Oh. In the meantime, somebody asked, is there a chance that by building solar panels on a planet closer to the sun, we would get more energy from the sun?
Absolutely. So there have been actually studies of placing solar power stations in the Vulcanoid asteroids. The Vulcanoid asteroids are actually closer to the sun than Mercury. They orbit inside. And there are various reasons we might want to do that. But yes, the closer we are to the sun, the more energy those stations would accumulate. You will lose a little energy in the transmission of the microwaves. It's not actually that much. So in geosynchronous orbit, which is a special orbit, you can place satellites in where they will appear to hang directly overhead. Even at night, they're just hanging up there. You will lose about 15% of the energy converting it and transmitting it down to the ground in microwaves. But that's actually similar to the amount of energy you lose by transmitting over power wires.
Can we get a mic over here in the corner, please? tech. In the meantime, while we wait for that, somebody asked, does the spaceship fly on fossil fuel? If yes, do you have a plan to replace it?
So New Shepard does not run fossil fuel. It uses hydrogen and oxygen, and when those burn, they make water. Steam is the byproduct. It's not harmful to the environment. Now, where does hydrogen come from? Currently, most hydrogen comes from natural gas. We crack natural gas to extract the hydrogen. But hydrogen in the future, and there's talk of a larger hydrogen economy, can very feasibly be made by simply a process called electrolysis, where you take electrical energy, you send it through water, and it turns into oxygen and hydrogen. So we are also developing ways to convert to that, and when we do, it will be basically a completely carbon neutral process to fly New Shepard.
That's amazing.
Yes. All of our future vehicles, the lunar landers, are also powered by hydrogen and oxygen propellants, and that is because if you go to the moon, you can refill by cracking the water there and turning it into rocket propellant.
And Sophia?
Hello, I would like to ask, because you were talking about like the projects on moon, are you somehow connected to the Blue Moon from Blue Origin, like the project?
We are, yes. Blue Origin is our Blue Moon is our project. I am the design review chair for the Blue Moon project. So although I'm associated a lot with the New Shepard project, I've been involved in all of the projects at Blue Origin. So basically, when they have a major design review, they want to bring in people from outside to really look at their design and get a fresh perspective. I lead the team that goes in there and evaluates that. So I've been involved in the Blue Moon project for years.
Perfect. Thank you so much, Gary. And that's all we have time for right now. We're going to take another short break and then come back for the future of art and design. But thank you so much. This has been epic.
Thank you.